Hello. In this video, we are going to learn about the different types of possible roots and how to determine when we have these different roots. So first, we need to learn about Descartes' rule, and it's a rule of signs. It will help us determine how many positive possible roots there are, how many possible negative roots there are, and then as a result, how many imaginary roots are possible. So to determine the possible positive real roots, you're going to look for the number of sign changes in the polynomial. To determine the number of possible negative real roots, you're going to look at the number of sign changes that occur whenever you plug a negative x into the polynomial. And then looking at the total possible roots, we are going to determine the total possible imaginary roots. So let's look at an example so some of this makes sense. We're going to find the possible positive, negative, and imaginary roots for the polynomial 2x to the fourth minus x cubed plus 2x squared plus 5x minus 26 equals 0. So first, to determine that, we need to know how many roots are going to be possible for this polynomial. There are going to be a total of 4 roots because the highest degree is the fourth power. So we know there are going to be 4 roots. We went over that in a previous video. Now we need to look at the possible positive real root. So let's examine and analyze this polynomial to determine the number of sign changes. So I'm going to look at the 2x to the fourth. There's no negative in front of 2, so I understand 2 is positive. And then I have a negative x cubed, so that's negative. And then I have a plus 2x squared, so it's positive, plus 5x, so that's positive, and then a negative 26. So going from the 2x to the negative x, from the positive 2x to the fourth to the negative x cubed, I see that went from positive to negative, so that's one sign change right there. Then looking at the negative x cubed to the positive 2x squared, that went from negative to positive, so that's a second sign change. Positive 2x squared to positive 5x, that was positive, positive, so that's no sign change. And then positive 5x to a negative 26, that went from positive to negative, so that's our third sign change. So we have possibly 3 positive roots, or, where's that? Okay, it's going to appear eventually. So the rule is every time you get a number of possible roots, then you have to subtract 2 from it. So it'll show up in a minute, but we will say 3 minus 2. So we're either going to have 3 positive real roots or 1 positive real root. I guess my animation is out of order. Okay, so now we need to determine the possible negative real roots. That is a real tongue twister. Okay, to do that, we need to plug in negative x. Anytime we raise a negative number to the fourth power, it makes it positive. So negative x to the fourth is going to make whatever x is, it's going to make it positive. So that's going to be 2x to the fourth. Anytime we raise a negative to an odd power, it keeps it negative. So negative x cubed times the negative that was already in front of it is going to make it positive. Negative x squared, that becomes positive, and it was already a plus 2, so that stayed positive. And then the 5 times the negative x is negative 5x, and then negative 26 are the same. So let's look at these signs here. So I see we have a positive 2, a positive x cubed, a positive 2x squared, a negative 5x, and a negative 26. 2x to the fourth and a positive x cubed, there's no sign change there. Positive x cubed and positive 2x squared, positive, positive, no sign change. Positive 2x squared to a negative 5x, positive to negative is one sign change. Ooh, my 1 didn't show up. And then negative 5x to negative 26, that's no sign change. All right, there's the 1 right there. Okay, so that means that we have possibly 1 negative real root. That's the only possibility. Oh, there's the or 1 right there. Okay, and because I can't, if I subtracted 2 from 1, it would be a negative number, so that's not a possibility. Let's look at this nifty little chart here. It's going to help us organize everything. We know that we have to have 4 roots total. No matter what, we have to have 4 roots. We also know that we can either have 3 positive real roots or 1 real root. And we know that we are going to have 1 a possibility of having one negative real root. So that means we need a total 4. So if we have 3 positive real roots and 1 negative real root, that means we're going to have 0 imaginary roots because 3 plus 1 is already 4. Now in the second row, if I have 1 positive real root and 1 negative real root, that's only 2. So that means that I have 2 imaginary roots. So those are all of our possibility combination of types of roots to total 4 roots. Let's look at another example. So we're still determining the number of possible positive, negative, and imaginary roots. This time our polynomial is x to the 5th minus x cubed minus 9x squared minus 3x plus 13. So we need to determine what are our number of roots to begin with. What is the degree of the polynomial? The degree is 5, so we know that we're going to have 5 roots. So now we need to look at the possible positive real roots. X to the 5th minus, let's just go ahead and look at all our signs. All right, x to the 5th minus x cubed, that's a positive to a negative, so that's 1. Negative x cubed minus 9x squared, negative, negative doesn't change. Negative 9x squared minus 3x, negative, negative, that doesn't change. And a negative 3x to a positive 13, there is a sign change there, so it's 2. So I have either 2 positive real roots, or 2 minus 2 is 0, or I have the 0 real roots that are positive. Now, what about negative? Well, I need to plug a negative x into this, and a negative raised to an odd is negative. And remember, a negative raised to an even is positive. So now, simplifying, I have a negative x to the 5th plus x cubed minus 9x squared plus 3x plus 13. Guys, if you're not sure, plug in a negative 1 into your calculator in parentheses, square it, cube it, whatever it may be, and see if it gives you a positive or negative. So let's look at all of our signs for this polynomial. I see a negative, a positive, a negative, a positive, and a positive. Negative x to the 5th and a positive x cubed. That went from negative to positive, so that's our first sign change. Positive x cubed to negative 9x squared. That's our second sign change. Negative 9x squared to a positive 3x. That's our third sign change. And then positive 3x to a positive 13. There's no sign change there. So I had 3 sign changes, so possibly negative, 3 negative real roots, and then 3 minus 2 is 1, or 1 negative real root. So let's look at our chart this time. We know that the degree of this polynomial is 5, so we have to have 5 roots. For positive, we had a possibility of 2 real roots or 0 real roots for the positive. Now for negative, we had 3 or 1, so now we have to do all of our possibilities. 3 or 1. So looking at our first row, if we have 2 positive real roots and 3 negative real roots, how many imaginary are we going to have? Well, 0, because 2 plus 3 is already 5. Looking at row 2, if I have 2 positive real roots and 1 negative real root, how many imaginary am I going to have? Well, 2, because 2 plus 1 is 3, so I need 2 more to equal 5. If I have 0 positive and 3 negative, I still need 2 imaginary to total 5. And if I have 0 positive and 1 negative, that means that I'm going to have 4 imaginary roots to total 5. Here's a piece of advice. Whenever you determine your number of imaginary, it will always, always, always be an even number. It will never be odd. We will dive into that in a future video as to why. But right now, I'm going to tell you and ask you to trust me that imaginary roots always come in even pairs. Well, duh, pairs are even. Imaginary roots always come in pairs. So that concludes this video on how to determine the number of possible roots for polynomials.